As I already said in the last video, I will now consider an example of partial integration where a cycling phenomenon occurs. The example concerns the following problem, where we have to compute the primitive of the function e to the power x multiplied by sine of x. Now, it's not clear at all that this technique will work, but one has to try something. So we have to assign functions g and f prime. Now, let us try to put sine of x into our g and e to the power x into our f prime. If we do so, then f of x is equal to the primitive of e to the power x is equal to e to the power x itself, and g of x equal to sinus x implies that g prime of x is equal to cosine of x. So if we plug this into our formula for partial integration, then we get that the right hand side is equal to the product of the functions f and g, which is equal to e to the x multiplied by sine x, minus the primitive of the function f multiplied by g prime. So this is e to the power x multiplied by cosine of x. And again, if you look at it, well, what did we get from this? Nothing much. But the only way to get further is just by trying to say something about this integral over here. And we will do so by applying the same technique. So again, we will put our cosine into the function g, and we keep e to the power x equal to f prime. So if g of x is equal to cosine of x, then g prime of x is equal to minus sine of x. Let us plug this into our formula, and so we get that this integral is equal to the product of the functions f and g, which is e to the power x multiplied by cosine of x, and we have to subtract the primitive of f times g prime. So this is e to the power x multiplied by minus sine of x, and I will put the minus sign in front by making this minus sign equal to the plus sign. That's very important to be extremely precise, otherwise you will not get anything useful at all. Now, again, so what did we get? We started with an unknown integral. We kept an unknown integral, and we have returned to our first unknown integral. However, you can do something by combining the two. So what do we get then? This first unknown integral is equal to e to the power x multiplied by sine of x minus something which we can substitute by this term over here. So we get e to the power x multiplied by cosine of x plus this unknown integral which we have on the left hand side as well. Now if you look at it carefully, then on the right hand side we have to subtract this unknown integral, so we can take it to the left hand side and we get 2 times this unknown integral. Let me note it in that way. And what is the right hand side? Well, this consists now of 2 terms, 2 functions that we know. Now the only thing left to do is that our unknown integral is equal to the right hand side divided by 2. And so we have solved our problem, miraculously, in some sense. And again, and of course, since a primitive is not unique, we have to add an arbitrary constant in this last expression. What we did solve in the process is also the primitive of the function e to the power x multiplied by cosine of x. Because what is it? Well, we do the same trick, but now we substitute this one by this term, and if you do the calculation, you end up with e to the power x cosine of x plus 1/2 times e to the power x sine of x plus an arbitrary constant. If I did correctly, let me check. We get this plus, yeah. Okay, so if you don't believe me, of course you can check it by differentiating, which you always should do to check yourself as well.